Cognitive biases are systematic ways that people's thinking deviates from rational logic. In a management setting, they show up as patterns that push leaders to over or underestimate risks, ignore important data, or stick with familiar ideas. Types can be grouped by source perceptual memory emotional, or by affect information processing judgment decision. Classification: most textbooks use 3 layers. Heuristics: mental shortcuts such as availability, what comes to mind first. Biases of judgment over confidence anchoring. Social biases: group-level distortions like conformity or groupthink. A practical analogy: imagine a manager looking at a weather forecast to plan a product launch. If they rely on the most recent sunny day availability and ignore the long-term trend-based rate neglect, they may ship too early and lose sales when a storm arrives. Recognizing that each bias belongs to a family helps managers pick the right tool to counter it. The 6 most common biases that directly affect everyday managerial work are explained below with simple stories. Confirmation bias: managers tend to search for data that supports what they already believe. Example: a CEO convinced that a new market is booming will highlight only the positive sales reports and ignore the failing pilot stores. Anchoring bias: the first number encountered heavily influences later estimates. Example: when negotiating a supplier price, the supplier's opening quote of $100 becomes an anchor. Even if the market price is $80, the buyer may settle around $90. Overconfidence bias: people overestimate the accuracy of their knowledge. Example: a product manager thinks a new feature will increase usage by 30% because it feels right, despite no test data. Status quo bias: the preference to keep things as they are. Example: an operations director resists adopting a new ERP system because the current spreadsheet process feels safe. Halo effect: a single positive trait, for example charisma, colors the overall evaluation of a person or idea. Example: an admired founder's strategic plan is accepted without critical review just because of his reputation. Groupthink: a cohesive team suppresses dissent to maintain harmony. Example: a product team unanimously agrees on a launch date, ignoring warning signals from a market analyst fearing conflict. Each bias can be pictured as a tinted lens. The manager sees the world through that color and may miss the true picture. Classic decision-making models assume that people evaluate options rationally. Biases warp those calculations. Expected utility (EU) is U equals sum of PI times U of XI, where PI are objective probabilities and U of XI is the utility of outcome I. If a manager suffers from overconfidence, they may overstate PI for a favorable outcome, inflating IU and choosing a riskier project. Bayesian updating uses the rule P of H given E equals P of E given H times P of H divided by P of E. Confirmation bias leads managers to overweight prior belief P of H and underweight new evidence P of E given H, so the posterior remains biased toward the original hypothesis. A simple analogy: think of a weather forecaster who trusts yesterday's sunny forecast, prior, and ignores the new storm radar reading, evidence. The Bayesian formula still puts high weight on sunshine, leading to a wrong decision. Thus, biases corrupt the inputs, probabilities, utilities that the models need, producing systematically flawed choices. Explanation: detecting bias quantitatively starts with data that can be measured: sales forecasts, project timelines, employee performance scores, etc. Statistical tests. T-tests or ANOVA can compare forecast errors before and after a known bias-inducing event, for example, a new CEO's first year. Chi-square tests can expose disproportionate selections, for example, too many yes answers in a risk assessment questionnaire indicating affirmation bias. Regression diagnostics. In a regression y equals beta sub 0 plus beta 1x plus epsilon, a high VIF variance inflation factor for a predictor that is an anchor. For example, initial cost estimate may signal anchoring bias. Residual plots that show systematic underprediction for high-risk projects suggest optimism bias. Bias correction factors. Once a bias magnitude is estimated, say forecasts are on average 15% too high, a correction factor C can be applied. Y hat sub edge equals Y hat divided by 1 plus B. where b equals 0.15. More advanced methods use Bayesian hierarchical models that place a prior on the bias term and update it with new data. By turning a qualitative feeling, "we're too optimistic," into numbers, managers can adjust forecasts and track improvement over time. Explanation-mathematical models let us experiment with bias in a controlled virtual organization. Agent-based models, abbreviation ABM: each agent, for example a manager, follows simple rules. A bias can be encoded as a parameter theta that shifts perception. For example, an anchoring rule might be estimate sub t plus 1 equals alpha times anchor plus open parentheses 1 minus alpha close parentheses times new info, where 0 less than or equal to alpha less than or equal to 1 is the anchoring strength. By varying alpha across agents, we observe how project budgets drift. Monte Carlo simulation with bias parameters: traditional Monte Carlo draws random inputs from a distribution. To add bias, the distribution is shifted. If the true cost C is distributed as normal with mean mu and variance sigma squared, but managers are over-optimistic by delta, we simulate C prime equals C minus delta. Running many iterations yields a biased cost distribution, showing how overconfidence inflates the chance of cost overruns. These simulations act like a flight simulator for executives. They can see the long-run consequences of a small anchoring bias, alpha equals 0.3, on a portfolio of 100 projects, such as 12% increase in total variance of returns. The key is to define bias as a numeric parameter, embed it in the decision rule, and then observe system-level outcomes. Debiasing is the practice of designing steps that force managers to pause, question, and correct their thinking. Pre-mortem: before a project starts, the team imagines that it has failed and writes down possible reasons. This flips optimism bias on its head, surfacing hidden risks. Red Team, an independent group, is tasked with challenging the main plan, similar to a devil's advocate. It combats groupthink and confirmation bias by forcing exposure to contrary evidence. Structured analytic techniques, methods such as analysis of competing hypotheses, a CH, require listing all plausible explanations for a problem, rating evidence, and ranking hypotheses. A CH directly reduces confirmation bias by making alternative views visible. Practical analogy: think of a driver checking mirrors before changing lanes. The mirrors are the red team that shows what's behind, while the pre-mortem is a quick what-if checklist before turning the steering wheel. These tools become checklists that can be embedded in standard operating procedures, ensuring bias checking becomes a habit rather than an afterthought. Case vignette: a regional manager forecasts sales for Q4 using a 10% growth assumption based on last year's performance. Historical data show a mean forecast error of plus 8%, optimism bias, end quote. What correction should be applied to the Q4 forecast ? Solution: adjusted forecast equals original forecast divided by 1 plus 0.08 equals 10% divided by 1.08, approximately 9.26%. Bias-adjusted forecast calculation: provide a table of projected revenues and ask students to compute the expected variance after applying an anchoring bias factor alpha equals 0.25 to the cost estimates. Formula: adjusted cost equals alpha times anchor plus 1 minus alpha times new info. Interpretation of statistical output: show a regression output where the coefficient for initial budget is 0.7 and the VIF is 12. Ask: what does the VIF indicate about anchoring bias, and how would you adjust the model ? Answer: a VIF greater than 10 signals multicollinearity, likely caused by the initial budget anchoring other variables. Remedy: drop or combine the anchored variable or use ridge regression. These questions blend theory, math, and real-world context, mirroring what MBA students face in consulting or strategy roles. Recognizing bias is not just a mental exercise. It ties directly to how a firm is governed, behaves ethically, and manages risk. Corporate governance: board committees can require a bias impact assessment before approving major investments, similar to a financial audit but for cognition. This creates accountability and transparency. Ethics: confirmation bias can lead to willful blindness to unethical practices. By instituting whistleblower reviews that deliberately seek contrary evidence, companies uphold moral standards. Risk management: Overconfidence and status quo bias often hide emerging threats. Integrating bias checks into risk registers, for example, a question, "Did we underestimate the probability because of optimism?" improves the accuracy of risk scores. An analogy is a ship's captain using both a compass, formal controls, and a weather eye bias awareness to navigate safely. Ignoring the weather eye biases can lead to a collision even if the compass points true north. Several psychological theories provide the scientific backbone for why biases exist. Prospect theory, Kahneman and Tversky, shows that people value gains and losses differently, leading to loss aversion bias. In management, this explains why a manager may reject a high-return project because it poses a small chance of loss. Bounded rationality, Simon, argues that decision-makers have limited information, time, and computational ability, so they use heuristics, the source of many biases. Dual process theory distinguishes a fast, intuitive system 1, prone to bias, from a slower, analytical system 2. Managers often rely on system 1 when under pressure, which explains snap judgments like anchoring. Understanding these foundations helps managers design interventions that move tasks from system 1 to system 2. For example, forcing a pause, using checklists, and recognize when the natural loss aversion of prospect theory may be distorting